In this video, I'm going to solve these three problems, which is taken from the book Principle of Physics, 10th edition. The title of the chapter is Temperature, Heat, and the First Law of Thermodynamics. First question. Consider the slab as shown in the figure. So the figure is given here. You have hot reservoir and cold reservoir. In between this hot and cold reservoir, there is a blue color material, which is nothing but we said here as slab. Understand? Suppose that slab has the length of 15 centimeter and the area of the slab is 105 centimeter square and the slab material is copper. If the hot temperature is given to the slab as 125 degrees Celsius and the cold temperature is 10 degrees Celsius, and finally a steady state is reached. If the steady state is reached, you have to find what is the conduction rate through the slab. So the slab material is given as copper, and that material has the length of 15 centimeter. So I convert this centimeter to meter, which is 0.15 meter, and the area of the slab is 105 centimeter square, which is 105 multiplied by 10 to the power of minus 4 meter square. And the hot temperature here we gave is 125 degrees Celsius and the cold temperature is 10 degrees Celsius. So we are going to find the conduction rate. For that, we need the thermal conductivity value of the copper. So the chart is given here. There are different materials have different thermal conductivity value. So for our case, we have to choose the copper material. So what is the thermal conductivity of the copper? The thermal conductivity of the copper is 401 watt per meter Kelvin. Clear? Now I'm going to use the formula for the conduction rate. The conduction rate formula is given by the relation P, which is equal to thermal conductivity of the material multiplied by area of the material multiplied by the change in temperature divided by the length of the material. Here the material is copper. So I'm going to substitute all the values here. So let's substitute the value one by one. The thermal conductivity of the copper is 401 multiplied by the area of the material is given here as 105 multiplied by 10 to the power of minus 4 multiplied by 125 minus 10 divided by the length of the material is 15 centimeter in terms of meter, which is 0.15. Now I'm going to calculate all these things. 401 multiplied by 105 10 to the power of minus 4 multiplied by 125 minus 10 divided by 0.15 gives the answer of 3228.05, and the unit for the conduction rate is watt. So better I can convert. I'm just going to write the value in terms of power. 3.23 multiplied by 10 to the power of plus 3. So this is the answer for the first question. So here you have to see this part. I did not convert this degree Celsius to Kelvin. Why? What's the reason? Because the change in temperature in terms of Kelvin as well as the Celsius gives the same answer. So I no need to waste my time. That's the reason I take the Celsius as it is here. Clear? If you want to convert in terms of Kelvin, again the answer will be the same. Clear? Okay, now we have to go for the second question. The volume of the solid aluminum ball with the initial radius of 20 centimeter which is later increased by 347 centimeter cube. So what is given in the first line? You have the aluminum ball, and that ball has the initial radius of 20 centimeter, and then you are heating that ball. When you heat that ball, what will happen? Its volume get increased. We studied these things in the thermal expansion. So we have three expansion: linear expansion, area expansion, and volume expansion. So this question is related with volume expansion. So we have to substitute the value in the relation of volume expansion. So what we are going to find in this equation, in this question, we are going to find what is the temperature change. That means we are going to find the value of delta T. Before we go to the solution, better we can recall the equation of the volume expansion. Delta V, which is equal to gamma V naught delta T. So this is our equation. So if you see the equation in the question, they gave the value of the change in volume, and this gamma, which is equal to 3 times of alpha. Here alpha is nothing but the linear expansion coefficient. Actually here the alpha for aluminum is a constant, which takes the value of 23 multiplied by 10 to the power of minus 6 per Kelvin. So that means the alpha value is a constant. So by that you can easily find the value of the gamma, and change in volume is already given in the question. And we are going to find the value of this delta T. For that we need the initial volume. So what I am going to do, before we go to this equation, before we use this equation, I am going to find what is our initial volume of the ball, because we have the initial radius. What is the value of the initial radius? 20 centimeter. Clear? So first of all, I'm going to find what is our initial volume of the aluminum ball. So the initial volume of the ball V naught, which is equal to, we know the formula for the volume of the ball. Actually, volume of the ball is nothing but the volume of the sphere, 4 over 3 pi r cube, but here the initial radius is r naught, so r naught cube. I'm going to substitute the value here. V naught, which is equal to 4 over 3 multiplied by pi multiplied by 20 the whole cube. So first of all, we have to find the value of the initial volume. So 4 over 3 multiplied by pi multiplied by 20 cube. So I got the answer as 33510. 33510.32 centimeter cube. So this is the value for the initial volume. Now we are going to use this equation for finding the value of delta T. Delta V, which is equal to gamma V naught delta T. We are going to find the value of delta T. I'm going to rearrange this equation. Delta T, which is equal to delta V over gamma V naught, where gamma, which is equal to 3 times of alpha multiplied by V naught. I'm going to substitute the value. Delta V is given as 347 centimeter cube. So what is the value of delta V here? Because they said increases by, so which means a change in volume, 347 centimeter cube. So I'm going to substitute the value here. Delta T, which is equal to 347 divided by 3 times of, what's the value of alpha? The value of alpha, that means the linear expansion coefficient of aluminum. Clear? Which is 23 multiplied by 10 to the power of minus 6. 23 multiplied by 10 to the power of minus 6 multiplied by, what is our initial volume? Our initial volume is 33510, 33510.32. Now we are going to calculate all these things to get the value of the change in temperature. 47 divided by 3 multiplied by 23 multiplied by 10 to the power of minus 6 multiplied by 33510.32 gives the answer of 150. What's the answer? 150 Kelvin. So what's the value of the change in temperature? 150 Kelvin. Now we have to go to the third question, which is the last question in this chapter. At what temperature is the Fahrenheit scale? That means you have to find the answer in terms of Fahrenheit, and that Fahrenheit scale, which is equal to 3 times of Celsius scale, and that Fahrenheit scale, which is equal to 1/3 of that Celsius scale. That means you have two parts. So what is what they give in the first part? Your Fahrenheit scale, which is equal to 3 times of Celsius. In the B part, they said the Fahrenheit, which is equal to 1/3 times of Celsius. So now, if you want to solve these questions, we have to use our general formula. The general formula for converting the Celsius to Fahrenheit is given by the relation C/5, which is equal to F minus 32/9. So you can use this formula to convert Fahrenheit Celsius or Celsius to Fahrenheit. So I'm going to use this formula for both A and B. And before we go to this formula, before we use this formula, we have to do some small mathematical steps. What mathematical steps we are going to handle? I am going to take my Celsius, which is equal to X term. By that, this equation will become F, which is equal to 3 times of X. Now, I am going to use this Celsius here. I am going to use this Fahrenheit as 3x here. Clear? So what is the formula? C/5, which is equal to F minus 32/9. I'm going to substitute the value of C as X. So X/5, which is equal to, my Fahrenheit is, which is equal to 3x. So 3x minus 32/9. And you have to take this 5 to the right hand side of the numerator. You have to take this 9 to the left hand side of the numerator. So by that, the equation becomes 9x, which is equal to 5 multiplied by 3x minus 32. Now, we have to multiply this 5 inside of the bracket. So 5 multiplied by 3x gives you 15x, and 5 multiplied by 32 gives you 160, and left hand side 9x. Now what I'm going to do, I'm going to separate x term one side, I'm going to separate the number one side. So for that, what I am going to do, I'm going to move this 9x to the right hand side. I'm going to take this minus 160 to the left hand side. So what will happen when you take this minus 160 to the left hand side? It becomes positive 160. When you move this 9x to the right hand side, this becomes minus 9x. So 15x minus 9x. So 15x minus 9 gives you 6x, which is equal to 160. Therefore, x, which is equal to 160/6. Clear? Now you have to divide 160/6. 160 divided by 6 gives you 26.66. So the value of the x we got here as 26.666. So I'm going to take only 2 digits, 26.67. And what is the unit of the x? We have to see this equation, x, which is equal to Celsius. So what is the unit of x? Degree Celsius. So now, once you find the value of x, we can easily find our Fahrenheit. What is our Fahrenheit? The Fahrenheit, which is equal to 3 times of x. So Fahrenheit, which is equal to 3 times of x. Take this x value, substitute here. By that, your answer will in terms of Fahrenheit. 3 multiplied by 26.67. 67 multiplied by 3 is 80.01. F, which is equal to 80.01. The unit is degree Fahrenheit. So this is the answer for the first part. In the similar way, you have to work out for this Again, I'm going to use the same mathematical steps I'm going to use here. By that, what will happen? Celsius, which is equal to x, therefore my Fahrenheit, which is equal to 1 over 3 times of x, and I am going to use the same formula, C over 5, which is equal to F minus 32 over 9. Take the value of C as x, and here also you have to substitute the value of the Fahrenheit as 1 over 3 times of x. So what will happen? X over 5, which is equal to 1 over 3 times of x minus 32 divided by 9. So I'm going to move this 9 to the left hand side of the numerator, and I am going to move this 5 to the right hand side of the numerator. By that, the equation becomes 9x, which is equal to 5 multiplied by 1 over 3 times of x minus 32. Now you have to multiply this 5 inside the bracket. So 5 over 3 times of x minus 5 multiplied by 32, again it's 160. On the left hand side we got 9x. So what is the value of 5 over 3? The value of 5 over 3 is 1.6666 comes. So I'm going to take 1.67. So 9x, which is equal to 1.67x minus 160. So I'm going to move the x term one side. I'm going to move the constant one side. So 9x, when you move this 1.67 to the left hand side, it becomes minus 1.67x. Right hand side, minus 160. So 9 minus 1.67 gives 7.33x, which is equal to minus 160. Therefore, x, which is equal to minus 160 divided by 7.33. So 160 minus 160 divided by 7.33 gives us 21.82 minus x, which is equal to minus 21.82. Again, the unit is degree Celsius. Now we have to convert the value of the Celsius to Fahrenheit, as we already used the equation here as F, which is equal to x over 3, right? So 1 over 3 times of x. I'm going to take this x, I'm going to substitute here. Therefore, F, which is equal to 1 over 3 multiplied by minus 21.82. So your answer becomes minus 21.82 over 3 is 7.27. What's the answer? The final answer, F, which is equal to minus 7.27 degree Fahrenheit. So this is the answer of your second question. Actually, this question is very easy, but the most important thing, you have to memorize the formula for the conversion of two scale, from scale Celsius scale to the Fahrenheit or Fahrenheit scale to the Celsius. Understand? So this is the way, in this way you have to solve this question, and the rest of the two questions also very easy. So you have to keep the formula in your mind. Understand? Clear? That's it. Thank you.